Hello children, welcome to Physics Lab. Physics is a very interesting subject and so is its experiments. Okay, so to begin with, let us start with some measuring experiment. The first experiment we'll be discussing is Vernier Callipers. Most of you might have read about Vernier Callipers in your school. Okay, so see, this is Vernier Caliper. Okay, I'll explain this in detail. We all know that given some rod or pencil or pipe or given some line to measure, what do you use? You will use this scale. I have a longer scale here. Okay, so you will just use your normal scale which you've been using right from your school. Even this instrument is used to measure basically length, we can say. Now, what is the difference between both of them? See, I'll draw a line which is about 1.5 centimeter and I'll ask you to measure. You will use your scale, you will place that and you will tell it's 1.5 centimeter. What if I draw a line which is more than 1.5 centimeter and less than 1.6 centimeter? That is, now the value of the line, the length of the line lies in between 1.5 centimeter and 1.6 centimeter. So, can we use this scale now? No, right? Because 1.5, most of you will tell it is 1.5 or most of you will tell it is 1.6. But that is neither 1.5 nor it is 1.6. So, we want the second decimal digit. Okay, and this instrument gives us that second decimal digit. Okay, this, if I am not wrong, this was designed in the year 1630s, if I am not wrong, okay, by some scientist by name Vernier. Okay, so he solved that problem of the second decimal digit. First, let us look into the diagram and then I'll explain how it gives us the second decimal digit. See, this is the diagram of Vernier calipers. Okay, and basically in this first experiment, we will be measuring the diameter of this bob. Okay, so when you look into this diagram, see, these two C and D are called the upper jaws, these two jaws A and B are called the lower jaws, and since I told that we will be measuring the diameter of the spherical body, I have already shown it in the diagram. This is where we are going to place our object to take the readings. And you can see letter S here, and this S stands for the screw. Okay, and this part which is visible here, this is the main scale which is exactly similar to the scale that you've been using so far. The speciality of this Vernier scale is this part. Okay, this is the Vernier division which makes this instrument more accurate when compared to your normal scale. And coming to the observation part, I have left one thing here. You can see here N. Okay, this is the metal strip and I'll show this in the instrument itself. Coming to the experimental observation part, you can see there are few things written here. The first one is value of 1 MSD. 1 MSD means 1 main scale division. Second one is total number of VSD. VSD stands for Vernier scale divisions. And then we have a formula here for LC. LC stands for least count. Okay. And what is this least count? Least count is the smallest measurement that any device or any measuring instrument can give. So, as science students, make sure that before using any measuring instrument, you will always note down its least count. Okay. And the scale which you are having, just you can hold that scale in your hand and you can see that 0.1 centimeter is the least count of the scale which you are using. Okay, and how do you calculate that? The very simple thing is, see, the first printed number is 0. After that, the next printed number is 1. Okay, I am telling it in a very simple way. Okay, so between the 0 and 1, there are 10 divisions. So 1 divided by 10 gives 0.1 centimeter, and that is the least count of the scale that you are using. Okay, then we have a tabular column here. So this tabular column, for each and every experiments you will have this observation part and the tabular column part, wherein you have to record your experimental readings. Okay, since it is the first experiment, you will be worried, what is this observation, what is this tabular column, there are so many things. Don't worry, all these are very simple. Once you start doing, you will get used to it. So observation is the initial things to be recorded, and later tabular column is something which records all your data, and finally we will calculate and then we will write down the result. So first we will see the Vernier calipers. This is the Vernier calipers. See, these are the two lower jaws, these are the upper jaws. This helps us, this spring helps us to move this, okay, and this is the metal strip. Okay, you can see some graduations on this scale. This part is the main scale. This scale is exactly similar to the scale that you've been using so far. And here you can see some more graduations. Okay, and this is the Vernier scale, which gives us the second decimal digit. Okay, and I'll just show how do we hold the objects to record various readings. See, these jaws are used to hold the bob. Okay, if we are doing an experiment using this bob, and if you are given some wooden box and asked to measure various dimensions of this box, then see, again you will be using these lower jaws only to hold it like this and record the readings. And if you are using, or if you are given some cylindrical object like this and asked to measure the internal diameter, then you will make use of this upper jaws and hold it like this. Okay, and to measure the internal depth of this, now we will use this strip. Okay, and this is how we fix it to take the readings. Okay. Now let me tell you how to record the readings. Okay, coming to the observation part, first I'll let you know the observation part. Our first observation was value of one's main scale division. As I told, it is just similar to your normal scale. See here, after 0 and 1, in between there are 10 divisions. Therefore, value of one main scale division will be 1 divided by 10 is equal to 0.1 centimeter. Then the second observation was total number of Vernier scale divisions. As you can see, these are the Vernier scale divisions and we have 10 divisions here. Therefore, total number of Vernier scale division is 10. And the formula of least count is value of 1 MSD divided by total number of Vernier scale divisions. That formula. Why we are using this formula? Because we don't want the least count for this scale alone. That is the main scale alone. We want the least count of the complete instrument. Therefore, to find out the complete least count of this instrument, we will use main scale data as well as the vernier scale data, because of which we have the formula least count is equal to value of one main scale division divided by total number of vernier scale divisions. And when we substitute, we will get 0.1 divided by 10, it is 0.01 centimeter. Am I clear? The least count of this vernier scale is 0.01 centimeter. So, the normal scale which you are using, the least count of that is 0.1 centimeter. Whereas, the least count of this particular instrument is 0.01 centimeter. Am I clear? Now, let us proceed and see how to take the readings. Now, let us see how to record the readings. As you can see, I have written two possibilities. This is possibility number 1 and this is the second possibility. Okay, so here we are supposed to note two readings. One is the MSR, other is the CVD. Okay, so how to take MSR? Which is the reference line to record MSR? The answer is the zeroth line. Zero, I have marked here, the zeroth line of the vernier scale is the reference to record the main scale reading. Okay, don't get confused. Here I have written MSD, here it is MSR, both are one and the same. This is main scale division, this is main scale reading, both are one and the same. Don't get confused. So, the zeroth line of the vernier scale is our reference, and as you can see, I have shown it through this dotted lines. The zeroth line is exactly coinciding with 2.1 value on the main scale reading. So, in this case, what you will write in the MSR column? 2.1. Okay, right. And coming to this case, I will come back to CVD. First, let us learn about MSR. Now let us consider the second case. Here, as you can see, the zeroth line is in between two divisions on the main scale. That is, it is in between 2.2 and 2.3. Now, what will be the reading? Can you write it as 2.2? Can you write it as 2.3? You have to think, right? Our common sense says it is neither 2.2 nor it is 2.3. It is something in between 2.2 and 2.3. Okay. So, what will be the main scale reading here? See, always keep it in mind. Whenever the zeroth line is in between two divisions on the main scale, always take the previous reading. Previous reading means here the line is between 2.2 and 2.3. Your main scale reading will be 2.2. Clear? I'll write it down here. In this case, our main scale reading is 2.1 centimeter, whereas in this case, in this example, our reading will be 2.2 centimeter. Clear? Okay. Here, both our common sense and the instrument are going hand in hand, 2.1 centimeter, it's fine. But here we know it's not 2.2 centimeter. It is 2.2 and there is something else also. Okay? And the something else is given by the vernier scale. Clear? So, now let us see how to record the vernier scale division. In the first case, say, zeroth line is coinciding exactly with 2.1. So, our job is completely done. Here vernier is 0. Okay, so the total reading for this particular example is 2.10 centimeter. 2.10 centimeter. Coming to this part, see. Now that our zeroth line is not coinciding exactly, then we have to just look into the 10 divisions and find out which division is coinciding exactly with any one line of the main scale. Let us have a look. See, 0 is not coinciding. After that, 1, 2, 3, 4, 5, 6, 7. 7 lines are not coinciding exactly. Whereas the 8th line is coinciding exactly, which I have shown in dotted lines also. So, in this case, CVD is 8. Clear? So, now we will use the formula given and we'll find out. I'll tell that later. But taking readings is very important. I hope it is clear. I'll repeat it once again. If the 0th line is coinciding exactly, write down that under the main scale reading, and 0 will be the Vernier division. Whereas if the 0th line is in between two divisions, always write down the previous reading for MSR and look for the division which is coinciding exactly with some line on the main scale. And in the example shown on the board, our 8th line of this CVD is coinciding. Therefore, 8 will be the CVD. I hope the reading recording part is clear to everyone. Then what we have to do? See, here you can see there are trial numbers written 1, 2, 3, and for the same object, for the same dimension, you have to repeat the readings at least 3 times. And why do we do that? To reduce our experimental error. Clear? So, more the number of trials, lesser will be the error in the experiment. Clear? So, a minimum of 3 trials is required to perform the experiment for any object or any dimension. 3 trials is a must. Minimum. Okay? And while performing, and one more thing, while performing this experiment, keep it in mind, if you are measuring the length and you will take 10 trials for this particular rectangular object, for all the 10 trials, make sure your MSR value will not change. Okay, only if there is any changes, that will be in your CVD only. Okay, and suppose if you are measuring the internal diameter, okay, you however trials you take 10 trials or you take 100 trials, no issues. The only thing is, for this particular cylinder and for the particular dimension, MSR value will remain same. Changes will be in the CVD, which we can eliminate by taking more number of trials and finally taking the mean value. I hope it is clear. So, in this experiment, very important thing is recording main scale reading and then Vernier, and then keeping in mind that for a given object, for a given dimension, MSR values will not change for any trial. The changes will be in your Vernier division only. Now, let us perform the experiment. So, since the aim of our experiment is to find out the diameter of this small spherical body, I am going to use this lower jaws and fix it here. Okay, and I can see that main scale reading is 2.5, and one more thing, while recording the readings, make sure you hold it normally in front of your eyes. Don't keep it in any angle and record the readings. Okay, so hold it normally, and here I can see that the MSR value is 2.5 and Vernier division is 1. Okay, now I will repeat the same experiment for 2 more trials and then tabulate the readings, calculate the total reading, and finally we will find out the mean value and write it in the result part. Now let us tabulate the readings. MSR for the first trial, main scale reading 2.5 and CVD 1. For second trial, MSR 2.5, CVD 2. Third trial, MSR 2.5, CVD 1. Now let us substitute these values in the formula. TR is equal to MSR plus CVD into LC. MSR for first trial 2.5 plus CVD 1 and least count 0.01. Make sure first you will multiply and then add the MSR. Okay. Finally, we will get it as 2.51 centimeter. Now let us tabulate this. First trial 2.51, second one 2.52, third trial 2.51. The mean value, we will add all the three, that is 2.51 plus 2.52 plus 2.51, and we will divide it by 3. It gives 2.513. So the reading is 2.513 centimeter. Now let us write that in the result section, and in your examination also don't forget to write the result because it carries 2 marks. Okay, so the diameter of a given spherical ball is equal to 2.513 centimeter is equal to 2.513 into 10 to the power minus 2 meter. Don't forget to write the final answer in SI units. For length, you know the SI unit is meter. So this ends the experiment.